Hello and welcome to this video on the effects of the Moon's distance from Earth. Due to the elliptical nature of the Moon's orbit, its distance from Earth can change a little over time. The Moon is approximately 31,000 miles closer to Earth at its perigee, or point closest to us, than at its apogee, or point farthest from us. The tides are one of the most obvious consequences of the Moon's separation from Earth. The Moon and Sun's gravitational pull on Earth's seas is what causes the tides. Which are the ocean's predictable rise and fall? There are 2 high tides and 2 low tides every day as a result of the Moon's and the Sun's gravitational pull on the seas. The gravitational attraction of the heavenly bodies, rather than the motion of the Earth or the seas, is what generates these tides. The separation between the heavenly body and the Earth affects how strong the gravitational attraction is. Higher high tides and lower low tides are produced when the Moon is nearer to Earth because of the larger gravitational attraction of the Moon. The converse happens with lower high tides and greater low tides when the Moon is farther away. Although the Sun's gravitational pull affects tides, it is less powerful than the Moon's because of the Sun's larger distance from Earth. The greatest high tides and lowest low tides of the month are known as spring tides, which are caused by the gravitational attraction of the Moon and the Sun. When the Sun and Moon are on opposite sides of the Earth and the Earth, Moon, and stars are lined up. Spring tides occur. Neap tides, which are the lowest high tides and greatest low tides of the month, are the opposite of spring tides. Neap tides happen when the Moon is in its first or final quarter phase and the Earth, Moon, and Sun are at a straight angle. The Moon's distance from Earth, its phase, and the alignment of the Sun and Moon with respect to the Earth are only a few of the variables that have an impact on tides. The complicated interactions between these variables can result in the tides that we see on Earth. It's important to note that the gravitational attraction of the celestial bodies, not the motion of the Earth or the seas, is what causes the tides. Additionally, contrary to popular belief, the Moon's brightness or its phases do not influence the tides. The occurrence and appearance of lunar eclipses are also influenced by the Moon's distance from Earth. When the Earth moves in front of the Sun and the Moon, obstructing the Moon's view of the Sun, an eclipse of the Moon takes place. The Moon might appear to change color during a lunar eclipse, taking on a reddish or orange hue. This is caused by the Earth's atmosphere, which bends sunlight and prevents it from reaching the Moon before passing through it. The light is then distorted or refracted as it travels through the Earth's atmosphere, giving it to an observer on Earth the appearance of being red or orange. The appearance of a lunar eclipse can be influenced by the Moon's distance from Earth in 2 different ways. First, because of its closeness to Earth, the Moon looks bigger in the sky while it is at its perigee. As a result of the light being refracted across a wider surface area, the Moon may look more dramatic and crimson during a lunar eclipse. Second, due to its increased distance from Earth when the Moon is at its apogee, it seems a little smaller in the sky. Due to the light being refracted across a smaller surface area, the Moon may look less spectacular and more pale or gray during a lunar eclipse as a result. It's important to remember that a lunar eclipse's appearance, rather than its occurrence, is affected by the Moon's distance from Earth. Only during the full moon phase, when the Moon is directly across from the Sun in the sky and completely lit by its own light, can lunar eclipses take place. The length of a lunar eclipse is defined by the relationship between the Earth, Moon, and Sun and is unaffected by the Moon's distance from Earth. Depending on how the celestial bodies align, lunar eclipses can endure for several hours. Depending on the Moon's distance from Earth, the length of a lunar month, the time it takes for the Moon to complete one orbit, can vary somewhat. The Moon's orbit is an ellipse, which has a top and bottom that are somewhat flattened, rather than a complete circle. This indicates that the Moon's distance from Earth may change over time, with a variation of around 62,000 miles between its closest and furthest positions. The Moon is significantly nearer to Earth and takes slightly less time to complete an orbit when it is at its perigee. It is a little bit further away and takes a little bit longer to complete an orbit when it is at its apogee. On a daily level, the variation in length is not apparent because it only lasts a few hours. The Moon orbits the Earth once every 27.3 days, and during this period, its distance from the planet can change by as much as 31,000 miles. As a result, a lunar month's length might fluctuate by a few hours according to the Moon's distance from the Earth. It's important to keep in mind that the length of a lunar month is not constant, but instead changes a little bit throughout time. The elliptical form of the moon's orbit, the gravitational attraction of the sun and other celestial bodies, and the tilt of the Earth's axis are only a few of the causes of this. The moon's distance from Earth can also have an impact on how brilliant it appears. Due to its closeness to Earth, the moon seems a little bit brighter in the sky while it is at its perigee. It seems a little bit paler at its apogee. Although they may be measured using specialized tools, these discrepancies are not visible to the human eye. The little brightness variations that take place as the moon transitions between its perigee and apogee cannot be seen by the naked eye. Numerous variables, including as the moon's phase, the quantity of dust and clouds in the Earth's atmosphere, and the alignment of the sun and moon with respect to the Earth, all have an impact on the brightness of the moon. The complicated interactions between these elements can result in the brightness of the moon as seen from Earth. It's important to keep in mind that the brightness of the moon fluctuates over time as a result of the celestial body's shifting positions. The full moon phase, when the moon is directly across from the sun in the sky and completely lit by the sun's light, gives the moon its brightest appearance in the sky. The quantity of dust and clouds in the Earth's atmosphere can also have an impact on how brilliant the moon appears. The moon's distance from Earth can also alter the Earth's gravitational field. When there is more dust and cloud cover in the atmosphere, the moon's light may be dispersed or absorbed, making it look fainter. The Earth's gravitational field is somewhat altered as a result of the moon's gravitational attraction when it is nearer to the planet. These fluctuations have little discernible impact on the surface of the Earth or on people. But they can change the orbits of satellites and other spacecraft. The strength of the gravitational pull that the Earth exerts on objects close to its surface is measured by the gravitational field of the planet. The mass of the Earth generates a gravitational field that keeps items on the planet's surface and in its atmosphere. The mass of the Earth, the placement and motion of the celestial bodies, as well as the form of the Earth, all have an impact on the gravitational field of the planet. The gravitational field of the Earth can also be influenced by the moon's distance from the planet. The moon's gravitational pull is greater when it is nearer to the planet and less when it is farther away. It is important to keep in mind that the gravitational field of the Earth is not constant, but instead changes somewhat over time as a result of the celestial body's shifting positions and motions. Additionally, there are differences in the gravitational field of the Earth depending on where you are on its surface. The moon's distance from Earth can also alter the length of a day, which is the period of time it takes for the Earth to complete one rotation around its axis. The Earth may slow down a little bit as the moon gets closer to us, lengthening the day by a fraction of a second. The opposite occurs, with a little shorter day, when the moon is farther away. These variations are, however, quite minute and undetectable on a daily basis. The Earth rotates around its axis, propelled by both its own momentum and the gravitational attraction of the celestial bodies, and this rotation determines the duration of a day. The location and motion of the celestial bodies, the Earth's shape, and the distribution of mass on the planet all have an impact on how long a day is. The duration of a day can also be influenced by the moon's distance from Earth. The moon's gravitational pull is greater when it is nearer to Earth and less when it is farther away. It's important to remember that the duration of a day does not remain constant over time, but rather changes gradually owing to the shifting the frequency of supermoons, which are full moons that are significantly bigger and brighter in the sky due to their proximity to Earth, can also be influenced by the moon's distance from the planet. Supermoons happen when the moon is full and at its perigee, or closest point to Earth. At this time, the moon's gravitational pull is stronger, making it look bigger and brighter in the sky. Although they are not all that uncommon, supermoons do happen more frequently when the moon is at its perigee. The moon's orbit is an ellipse, which has a top and bottom that are somewhat flattened, rather than a complete circle. This indicates that the moon's distance from Earth may change over time, with a variation of around 62,000 miles between its closest and furthest positions. The moon orbits the Earth once every 27.3 days, and during this period, its distance from the planet can change by as much as 31,000 miles. Thus, depending on how far away from Earth the moon is, supermoon frequency might change. It's important to remember that supermoons don't happen all that often, rather, they do so more frequently when the moon is at its perigee. Supermoons are larger and brighter than typical full moons, but the distinctions between the two cannot be seen without specialized equipment. Eclipses are astronomical occurrences that happen when one celestial body passes in front of another, preventing the light from one body from reaching the other. The moon's distance from Earth can have an impact on the timing of eclipses. Eclipses come in two varieties: solar eclipses and lunar eclipses. Solar eclipses happen when the moon moves in front of the sun, preventing sunlight from reaching Earth. Lunar eclipses happen when the Earth passes in front of the sun and the moon, preventing the moon from receiving light from the sun. Eclipses happen when the Earth, moon, and sun are in a specific alignment, which is defined by the location and motion of the celestial bodies. The timing of eclipses can be impacted by the moon's distance from Earth in two different ways. First, the moon is somewhat closer to Earth and takes significantly less time to complete an orbit when it is at its perigee. Due to the moon's earlier than anticipated arrival at the required alignment, eclipse time may deviate somewhat from expectations as a result. Second, the moon is a little bit further away and takes a little bit longer to complete an orbit when it is at its apogee. As a result, eclipse time may change somewhat from what is anticipated because the moon will achieve the required alignment. The timing of tides, which are the regular rise and fall of the oceans on Earth brought on by the gravitational attraction of the moon and the sun, can also be impacted by the moon's distance from the planet. Tides occur when the Earth, moon, and sun are in a specific alignment. The time of tides is regulated by the location and motion of the celestial bodies. The timing of tides can be impacted by the moon's distance from Earth in two different ways. First, the moon's gravitational pull is stronger when it is at its perigee because it is significantly closer to Earth. Due to the moon's larger gravitational attraction, tides may come a little earlier than anticipated, which can cause them to occur a little later than anticipated. Second, the moon is a little further away and has a smaller gravitational attraction when it is at its apogee. Due to the moon's lesser gravitational influence, tides may come a little later than anticipated, which can cause them to occur a little later than predicted. It is important to keep in mind that tidal timing changes throughout time as a result of the celestial bodies' shifting positions and motions. Other variables that influence the tides include the moon's phase, the sun's and moon's positions in relation to the Earth, and the configuration of the planet's coasts.